Thank you. Thank you very much. Well, today we're here to talk about lube oil system risks. Yep, we've been talking about the fire protection risks for a little while, and now we're going to talk a little bit about both. We'll talk about more of the mechanical stuff on the lube oil systems first, and if you stick around, you're going to find out how to control under turbine lube oil fires. You're going to find out the magic trick. Okay, let's get going. And first off, what are lube oil systems? We'll go through what can go wrong with the systems, how we can predict it before it happens, and then, like I said, we'll talk about the solution to under turbine fire protection. All right, well, what are lube oil systems in power and chemical plants? They're the systems that are there to basically provide a clean source of lubrication for many large machines. They can also cool the oil and condition the oil. So the big machines, steam turbines, combustion turbines, large compressors, large fans, many of these type systems, motors, engines, they'll have their own small lube oil system integrated to it. As we get bigger and bigger, like in combustion turbines and steam turbines, we start to have remote lube oil reservoirs. And we'll talk a little bit about those because those are the ones that cause the big losses that the insurers get interested in. So here's a lube oil system. And you'll notice that pipe looks pretty wide. I'll explain that in a minute. This is a bearing on a steam turbine, and you see the sprinklers up there. They're there in case this lube oil gets out and catches on fire. Not sure really what good they are, but a lot of fire protection engineers swear by them, and they really want them bad. So if it's not too expensive, we try to put them out there. But I've always felt like a 10-foot by 10-foot pool of oil on the turbine deck was not going to cause much damage to the turbine building. It's when it starts to run down and go into the basement that we really have a problem. So we can talk about the right way to control turbine lube oil fires. First, let's understand how a turbine lube oil system works. Remember, we said that the oil needs to be returned back after it does its job at the bearings and cools and lubricates the bearings. It has to go back and get cooled off itself. It has to be cleaned. Potentially, there could be moisture in it that has to be separated. Well, along its journey, it follows a concentric pipe. Okay, there's a pipe within a pipe. And basically, the point is that the high pressure, the supply, is going to be on the inside pipe, the internal pipe, and that's how the oil gets up to the bearings. Then when the oil is returning to the reservoir, it flows through the outer wall, or in that interstitial space between the inner pipe and the outer pipe, and back to the reservoir. You notice I drew a steam line in there. It's hot, so if this lube oil line breaks anywhere along the way, you know, it's got a flash point of up to 400 degrees, but that's not going to help it when the steam line's 1,000 degrees Fahrenheit. So that could lead to a fire if that were to occur. Here's a little more sophisticated drawing of a lube oil system. Hopefully you can follow it all. I'm not going to take you through it. You have plenty of time to take a look at it. It just basically shows you from the generator to the bearings to all the different parts that need to be lubricated down to the reservoir. Here's what I like, the real world. Notice that there's multiple pumps on this reservoir. Now this is a small reservoir, it's a small power plant. But you see two AC pumps, one's a backup to the other. You see a DC pump, that's a backup to the AC pumps. You notice the power supplies leading up to these pumps, and you'll find these are in conduits, but there's some insurance carriers out there that really push wrapping these power supplies with fireproof thermal wrap, basically, or separating them by 30 feet, 50 feet, whatever you analyze to be a necessary distance to protect it from a single fire. I argue that the only fire that can take out all of these power supplies for all of these pumps is a lube oil fire. It's not going to be a trash can fire. It's not going to be a cable fire. There's nothing else down here. The only thing that's going to burn big enough, hot enough to burn up power supplies for all three of these pumps has to be a lube oil fire. In that case, we don't want to feed that fire. We want to shut this power off to all these pumps so we're not putting oil on the fire. Yet, there are insurance companies, and an FPA 850 still says to separate these things like it was a nuclear power plant safe shutdown system. It's not. It's important to shut down the power plant, but once you've lost the oil containment, your problems are much bigger than trying to protect those bearings. You're already wiped the bearings. If the oil is not in containment, you don't have pressure going to the bearings, so you wipe them. Okay, so that's basically what I think about separating the power supplies. Okay, what can go wrong with lube oil systems? Well, we can wipe the bearings. That will happen on a loss of pressure or flow, or if we have some sort of debris or water in the oil. Sometimes you can even dilute the oil with fuel. If you had a cross-contamination issue, that would decrease the viscosity. You can have a lube oil fire when you have a loss of containment. Your rotor and your generator are going to get severely damaged during this it's severely vibrated. Sometimes they get damaged, sometimes they don't, but you have to look. If you ever have a lube oil incident that shakes the unit, certainly to the point if you had a fire, but even before that, if you just had a bearing get wiped, you're going to have to look up and down the rotor to see, is there more damage? Let's talk about bearing wipes. What do they look like? Well, I've told you before that a bearing wipe at a big steam power plant or big, commercial power plant is going to cost around $5 million to get in and repair. The problem with these things is that, when the oil is interrupted, you get scoring and gouging, and that's what you see here is all this metal has been removed from the bearing, and it's going to have to be redone. The bearing's going to have to be repoured, new babbitt material. But all that babbitt went down into the lube oil reservoir, right? Now we've got contaminated oil in that lube oil reservoir. So a bearing wipe is one of these things that you don't just fix the bearings, then you have to go and decontaminate all that oil. And you have to be really careful when you do it and do it thoroughly. You see that little title up there, that little text that says micro dieseling. I just wanted to, probably spelled it wrong, but I wanted to share with you a neat phenomenon I'd never really was aware of until a few years ago. I started reading up on lube oil. And that is that when the return line comes back to the lube oil tank, if the return oil does not enter the tank below the liquid level, that is, if the return oil drops in through the vapor space down to the surface of the liquid, as it does that, it's bringing air, just tiny little amounts of air bubbles down into the oil. Those tiny little air bubbles will get eventually sucked into the pump and then pushed out into the system. As those tiny little air bubbles go through the tight spaces in the bearings that they have to work and navigate their way through, they get compressed, okay? And what does it take to make a diesel engine run? Fuel, oxygen, and pressure, right? All we have to do is squeeze that air tight enough, and now, in the presence of fuel, we have heat, fuel, and oxygen. So that's what will basically create a tiny little burnt, dieseled piece of carbon. So those can build up. So a system that has that return that way, over time may build up and build up and build up varnish that have no idea where it's coming from or why it's getting there. All right, the high vibration that can occur when we lose lube oil will or sometimes cause blades to liberate. If a blade liberates, we're going to severely shake the machine, but we're also going to shake all the piping that's connected to it. Notice this is a concentric pipe. It's broken. It was actually in a large event, and this is where the leak developed. When the leak got started, it went down and found a steam line, ignited. We had a fire in the bearings of the steam turbine. Of course, the turbine is all disarrayed now. The wreck itself destroyed the turbine. The fire really didn't add anything to the claim from the standpoint of having to replace the turbine and the bearings and everything that was involved upstairs. Downstairs was where all the subsequent damage was that didn't need to be if we could have controlled that under turbine fire properly. All right, so how can we predict when something's going to go wrong with our lube oil systems? They have tests, right? We can look at the lube oil analysis to figure out what's the condition of our oil. We can look at vibrations. So we'll get into it. We'll look at the operating profile, what different operations, when I say that, it can be a peaking plant that starts, only in the afternoon. It could be a plant that runs base load. So we're talking about operational profile, ups and downs. And finally, we'll talk about a warning to everybody to beware of combined lube/control oil systems. When you have a combined lube and control oil system, there's some dangers to be aware of that I'll cover in a few minutes. Alrighty, so let's get into the tests. What are we looking for when we do a lube oil test? What those lube oil analysis? What are the insurance company engineers looking at when they look at that report? Well, they're looking at physical properties, they're looking at contamination and performance properties. So the physical properties are going to be things like the viscosity, the acid number, the base number, the water. So we're trying to look at, will the oil physically and chemically work? Then we're looking at contamination. Is there something in the oil that shouldn't be there? Particles, wear metals? Because if we find wear metals in there, then that's a clue as to what is causing or what kind of damage is occurring to our equipment. So the lube oil is a nice place to investigate other pieces of equipment, all those big machines, the compressors and the fans and the gas turbines, the things that I listed before. It's a great way to figure out if there's problems with that machine based on its oil. And then finally, performance properties. In the presence of moisture, lube oil will oxidize. So there are there are additives to prevent that oxidation. There's additives to prevent rust. There's additives to prevent foam. But basically, if the oil doesn't have enough of its additives, it's not going to pass these tests. So that's what we're looking for in a nutshell, and we'll show you kind of a list of what they look like, some ASTM numbers if you're in an area that uses ASTM. Not comprehensive, just wanted to give you an idea what it looks like. So in vibration monitoring, I've seen this before. We had an issue with the lube oil system. It was actually a cracked nipple, so we didn't have complete flow going where we thought it was going, and we would get vibration. But if we increased the flow rate through the lube oil system, we basically were leaking faster, but we were making up for that leak. The vibrations went away. So there's a way to diagnose your machine problems or your oil problems if you have vibrations. So it could mean that you have contaminated oil or that you have some problem with the flow of oil. All right, I mentioned the operational profile, peaking units, they're going to heat up and cool down, right? And every time you do that, you expand and contract. And every time you have seals that can leak air, the air has moisture. So it's just breathing basically over time in and out. And you're going to notice a degradation of the oil maybe faster. Now, what could preserve a machine that peaks or cycles is that it may not be a steam turbine. It may not have all of the extra heat that comes along with a steam turbine. So in that case, the oil might last longer. But you don't want to ignore the oil if you have a peaking application. I told you I was going to warn you about combined lube and control oil systems. Now, what I'm talking about here is a system that not only provides the oil to lubricate the bearings, but it provides the oil that's used to open and close valves, right? For all of the hydraulic controls of the turbine, those are now managed by this control oil system. The huge difference, and you have to be careful because it all depends on specific design. The design I saw where I had a big fire, no fire, but it could have been huge. The control oil was basically in its own isolated piping, separate from the lube oil. So when the valve needed to be opened, they pushed the oil a few inches, and then when the valve needed to be closed, a few inches back. The oil never flowed through the pipe. It just basically went back and forth and just sat there. So any of that moisture that was getting in was never getting cleaned out in the reservoir or conditioner. Eventually, we had the motorized generator incident, and when we wiped some bearings, so we were cleaning the oil, and what we found was that we put fresh, brand new oil in. As we did a circulation, it just got dirtier and dirtier. And we traced it down to the control oil piping. It had never gotten flushed, and it wasn't drained when the whole system would drain. So all that dirty old oil was in there. Now, the water settles to the bottom, and then it starts to corrode out the bottom of that pipe, which was pickled, or basically a sacrificial layer of corrosion was placed in there during the design to keep it from corroding. But it can't last, for 30 years. So then you start to get corrosion in your control system, exactly where you don't want to have anything sticking. Check your control system, because a lot of people have trouble with their control valves, their hydraulic controls, and it very well may be because of the way that oil is not being constantly cleaned. All right, we're here. Welcome to the solution to under turbine fire protection. I've thought about this for quite a while, and I've got a long list of experience of putting in under turbine sprinkler systems for lots and lots of money. And, it was NFPA compliant. It made the insurance companies happy. Was it necessarily going to improve risk? I'm not sure anymore, because I've come up with another way to look at under turbine lube oil fires. So let's talk about what is a lube oil fire. It can be a spray or torch fire. It can be a three-dimensional fire, or it can be a pool fire. So let's go through and talk about each of these, and then we'll talk about how we can manage them. All right, spray fires are basically when we have a flange leak or a broken pipe, something where the pressurized oil is going to spray out. In my personal experience in investigating spray oil fires, the damage is located right there where that torch is. It's just like if you were holding a welding torch and you just held it in one place. It's really going to damage everything right there, but it doesn't necessarily spread if it's just heating metal. If there's some interstitial fuel, some intervening fuel, then we can see where a spray fire might progress. Now, how do we handle spray fires? We put flange guards on. Then if the pipe has any kind of motion, if there's any kind of break in the seal, the flange guards take the spray and then they turn it into a drip. So it just goes down and forms a pool fire. Okay, keep that in mind. We've just turned a spray fire to a pool fire with just flange guards, no automatic protection. All right, what are three-dimensional fires? Three-dimensional fires are basically fires that aren't down on the ground. They start at an elevation and then they flow down to the ground and form a pool fire. So in my previous experience running a fire school, I was so lucky to get to watch this phenomenon occur. We had a 12-foot ceiling, we had a 10-foot rack, and in the rack we used to simulate cable tray fires. We had Excelsior, which is just shaved pine straw. That stuff burns very quickly, and my job that day was to stoke the fires. So up on that 10-foot shelf, or that 10-foot rack, we had a chunk of Excelsior, and what happened was, after we lit it, it takes off, the flames hit the ceiling, the jet hits the ceiling and spreads out, and now we start to see the smoke layer fill from the roof or the ceiling down. But once it got 2 feet down and got below the level of that fuel, it started to darken down. There's no air for that Excelsior to burn anymore. What was amazing for me was, as I was watching this, a chunk of Excelsior fell off the rack down to the floor. It immediately burst into flames because it had air now. That fire took air up into the upper level fire and it took off. So the idea that I understood now was that if you have some fire below that can pump oxygen to the fuel above, you will intensify that fuel above. If you put a fan down there, it would intensify the fire above. But in a 3D fire, what we've got going on is a pool fire on the bottom, intensifying the oil coming down from the top. How do we deal with it? Put out the fuel fire, put out the pool fire, right? Control the pool fire. How do we control under turbine fire pool fires? My idea was basically a header along the turbine building wall, so you don't have to have hangers and put the pipe all over and have to have outages and shut the plant down to put this in. And on this pipe, you're going to have nozzles. And these are going to be big nozzles like firefighter nozzles, 2.5-inch nozzles. You're going to duct foam, or I'd like F500 micelle encapsulator, into the water. You're going to spray it on the floor through this pipe, and that you're just going to cover the floor with foam or F500. If you do that, the spray fire that turned into the pool fire gets controlled. The 3D fire that gets turned into the pool fire gets controlled, and the pool fire itself gets controlled. Now we've controlled the under turbine lube oil fire hazard. Thank you very much. I was hoping that I could get this out quickly. If there are any questions, please jump in and send me a comment. If you disagree with something in there, please let me know. If you'd like to come on and be interviewed, I'm looking for anybody who's willing to chat energy risk engineering with me. Come on.